In this video, I want to walk through another example of rewriting a function that is given to you in standard form and writing it in Vertex form. So if you just look at your worksheet, we're going to walk through number 2. So this is your homework that's going to be due tomorrow. It's on the worksheet that I gave all of you yesterday. So number 2 states y is equal to x squared minus 2x minus 5. And the goal is to take this function that is written in standard form and to rewrite it in what we call vertex form. So we know that standard form has this general appearance, so y is equal to a x squared plus b of x plus c. So anytime that we have a quadratic, that is an expression with a degree of 2, in this form, we call this standard form. So standard form. And the goal is to take this expression that's in standard form and to put it into vertex form. Now, what does vertex form look like? Vertex form is going to have this general appearance, where I have y is equal to lowercase a, and then we'll have x minus a number that we call h, and then squared plus k. And we call this vertex form. This is vertex form. So I'll just write it here, vertex form. That's kind of a bad F. Let's rewrite that form. Vertex form. So we want to take our expression, which is currently in standard form, and rewrite it in vertex form. And it's pretty easy, and it's very straightforward whenever our coefficient of the squared variable term is 1, which it is in this case, because you know right in front of that x squared, I could just rewrite this as y is equal to 1 x squared minus 2x minus 5. So there is one additional step that we have to do when this coefficient of the squared variable term, that is, I find my term where the variable that we have is squared, and I look at its coefficient. Here it's 1. So there's one step that I'm leaving out, but in the next EduCanon video, we're going to look at another example where that coefficient is not 1. There's just one extra step that we have to add in to convert a function in standard form to vertex form. But before we do, let's just look at this example first. So y is equal to x squared minus 2x minus 5. So if you watched the EduCanon videos from yesterday, what I said was, let's start by rewriting this expression, but let's leave a gap between this term, negative 2x, and the constant term, negative 5. So we get y is equal to x squared minus 2x. I introduce my gap. I'm just going to leave a space between this negative 2x and the negative 5 and the negative 5. So now, I want to ask you the question, what do I need to add to these first two terms? You'll see that these first two terms, okay, x squared minus 2x, what do I need to add to these two terms to complete the square? Yeah, so hopefully you guys are feeling pretty good with this by now. If you remember from the last few videos, to figure out what we need to add to these two terms to complete the square, we find the coefficient of the term, of the x term, okay, not the x squared term. We want to find the coefficient of the x term, which is negative 2, and we want to half it and square it. And that result will tell us what we need to add to complete the square. So let's do that. So I'm going to go over to the side here in a different color, and I'll say, okay, negative 2, we're going to half it by dividing by 2, and then square it to find out what we need to add to this to complete the square. So we say that is equal to, so negative 2 over 2, that's just going to be negative 1. And then negative 1 squared is 1. Just 1. So we just need to add a 1 to that 2x. Now I'm going to do this in a different color. I'm going to do it in a light blue. So that means we want to add 1 here to complete this square. So now we have these three terms, and we call this a perfect square trinomial. So we call it a trinomial because there are three terms. Just like triple would be three. Here we've got three terms, one term, a second term, and a third term. And now we have a perfect square trinomial because we have completed the square. But to make this mathematically legal, though, we can't just add 1 to this equation because then it changes our function. If we just add something to it, that makes this into a new expression. So we want to make sure that this expression is the same as what we started with. And the way that we do that is by adding 1, but then we just turn right back around and we subtract 1. Now, that's really strange. I know this is weird. Why would you add 1 just to subtract 1 from it? And the reason is because plus 1 minus 1, okay, that's just 0. If we add 0 to anything, it's not going to change our function. This is a math trick that you're going to see over and over and over again in your future science classes. When you guys go to college, you're going to hear mathematicians talk about adding 0 to rewrite functions or to put them into a form that's a little easier to work with. So plus 1 or 1 minus 1, that's just 0. So we're not changing anything by first adding 1 and then subtracting 1. So now I can go back, I'll go down here and I will rewrite my expression. I have y is equal to x squared minus 2x plus 1, and then to get rid of that, let's go ahead and combine these two. Let's do negative 1 minus 5. That's going to give me negative 6. So negative 6. And let's group. Let's just group this. Now there's no real reason why I'm grouping it, just that way you can see it a little bit more. What are we working with? So let's group these first three terms together. Now, yesterday on our worksheet that we did in class, you were given a lot of these. I think it was on part B or part 2 of the worksheet that I gave you yesterday. I think it's titled In Class Notes 10. And after you completed the square, we factored it. And there's a really easy trick that we use to factor expressions that are perfect square trinomials like this one. So this is a perfect square trinomial. We've completed the square, which makes this a perfect square trinomial. And remember, yesterday we said that we can easily rewrite these expressions in a general form that looks like this. Okay, so moving from this to that is factoring. Now, again, I want to be very clear. The factoring method that we went over a couple weeks ago, where we did A times C, in this case it would be 1 times 1, and then we asked ourselves what two numbers can be multiplied together to give me 1, but be combined in some way that is added or subtracted to get negative 2, and then we found them, and then we split our middle term up, and then grouped them, and then factored. That was a long, arduous process. So I really recommend when you're completing the square, just use that trick. And the trick is, what do we need to add in here? What do we need to add in here or subtract in here to factor this expression? So hopefully you remember that to figure out what we need to add in here or subtract in here to factor the part in these yellow brackets or these yellow parentheses is just going to be the coefficient of x. Okay, the coefficient of x divided by 2. So here we've got negative 2, and we half it by dividing by 2, and we get negative 1. Don't forget the negative. So if we half negative 2 divided by 2, that's negative 1. So this part of the expression is this. Okay, it's the same as that. It's just we factored this. So use that trick to make your life a lot easier. And now if I rewrite my expression, I have y is equal to x minus 1 squared. So I just bring the y down, the equal sign down. I haven't changed my 6, so I'm just going to leave that 6 minus 6 on the end. And there we go. We've rewritten our expression in standard form, or in vertex form. So this is in vertex form. Now this expression is the same as this expression. Now, what I would like for you to do, go to the Desmos application, plot this function in Desmos, and then also plot this function in Desmos. If you did this process correctly, you'll see that your two parabolas that you get are exactly the same. But go ahead and test it yourself. I want you to prove it yourself. Plot this in Desmos, and then plot this in Desmos, and see if your functions look the same. Now there is one more thing that I want to do before we conclude this video, and I'm just going to go over to the next slide where I've already rewritten this expression. Okay, so let's go to the next slide. So here is the expression that we have on the previous page, which really, this should be a -6. Let me scratch that. I'm just going to scribble that out. That should be -6 there. So now you can see that we have the exact same expression. So y is equal to x minus 1 squared minus 6. Go to the other side. Now we have x minus 1 squared minus 6. So this is exactly the same as what we had on the previous slide. And off to the right-hand corner, I've written the general form of a quadratic that is in standard form, which the 2 is getting cut off. It is there, but I know you can't see it, so I'll put my 2, so that's squared. So this is the general form of a quadratic that is in vertex form, and here's the expression that we got on the previous page. Now, just take a moment and compare this expression to our general vertex form, and see if you can identify A, see if you can identify H, and see if you can identify K in our expression. So hopefully by comparing these, you were able to identify each of these variables. So A here is the number in front of this expression that's in parentheses that's being squared. So I'll look at my expression. What number do I have out here? So even though it's not written explicitly, we know that there is a 1 out there. Okay, there's a 1 out there in front of these parentheses. So we would say that A, in our case, A is equal to 1. So it's this one that I'm looking at. So we know that A is the number in front of the parentheses. So A is 1. Now B, or not B, H here, negative H, minus H. Here we've got minus 1. Minus 1. So what we have here is H is equal to 1 as well. H is equal to this one. A is equal to that one. So what is K here? K is whatever's being added to this first term. So in our expression, we're subtracting 6. So in this case, we could say that this is adding a -6 to make it look more like this expression, or you could just go ahead and say that K is equal to -6 in our case. Now, in a couple videos from now, I'm going to explain what each of these mean and why or how we can interpret these on a graph. But for right now, just go ahead and go to the next EduCanon video where we're going to walk through another example of rewriting a quadratic in standard form into vertex form. Except in the next example, we're not going to have a coefficient of 1 in front of the squared variable term. So go ahead, go to the next EduCanon video and just let me know if you have any questions.